In this video, we are discussing the Oracle Container Engine for Kubernetes on Oracle Private Cloud Appliance. Oracle Container Engine for Kubernetes is a managed Kubernetes service that enables organizations to deploy, manage, and scale containerized applications within their on-prem infrastructure. This integration offers a consistent experience with Oracle Cloud Infrastructure, allowing for seamless application portability between on-prem and cloud environment. OKE is Managed Kubernetes Service, providing a fully managed Kubernetes environment, handling the complexity of cluster operations, including control plane management, worker node provisioning, and scaling. It provides high availability. The service ensures high availability by distributing control plane components across multiple compute instances. It supports the deployment of multiple clusters and node pools, accommodating varying workloads and scaling requirements. OKE also integrates PCA's networking and storage services, providing efficiency resource management and performance optimization for containerized applications. This helps improving the developer productivity and time to market, and is a part of PCA. There's no extra charge consuming this service. By leveraging OKE on PCA, organizations can modernize their application infrastructure, enhance operational efficiency, and maintain control over their data and workloads within their own data center. Here are the steps in provisioning OKE clusters. This slide highlights the tasks splitting between administrator and user, emphasizing resource creation and management. For administrator tasks, begin with creating fundamental resources within the PCA compute enclave. We have to define the tag name, Oracle PCA-OKE/cluster_ID, and we have to create an OKE dynamic group. For user tasks, focusing on creating necessary network resources using terraform script for ease of use. So we have to provision components like VCN, subnet, internet gateway, NAT gateway, route table, security list, and etc. Public IPs are required for the VCN, as VCN with DRG are not yet supported when I record this video. We need to ensure the subnet name includes control plane, as is mandatory, because OKE will provision all Kubernetes control nodes in this subnet. Next, I will demonstrate the step to create an OKE cluster. Additional note, load balancer on OKE will be auto-provisioned if a load balancer is requested in OKE cluster. A block volume on PCA will be auto-provisioned if a persistence volume is requested. And we need to manually set up the proxy in CRI-O, which is the container runtime interface for Kubernetes. Let's start with the demo. In this demonstration, I will show you the step for a user to provision OKE cluster. In PCA documentation, there is an example Terraform scripts to provision necessary network resources for OKE. I have already downloaded all these scripts into one of my Western hosts. And in this Western host, I also set up the OCI command line interface so that I can interact with PCA directly from this Western host. You can see that I can run some OCI command to talk to PCA backend, and everything seems to work correctly. In this Western host, let me show you the content of the .oci config file. You can see that I have a profile called default. I have already configured the user, the fingerprint, tenancy, region, and key file. Okay. Cert bundle is necessary if you would like to run OKE on this machine, but I just put it. Actually, this one is not necessary for the config file. Let me show you another file. It's OCI underscore CLI underscore RC file. And here is where we have to inform OCI CLI in the default profile, but with the search bundle that I have to use to connect to PCA, then the compartment ID. In OKE Demo folder, we have a number of Terraform files download from the PCA documentation. After I download, what I did is I modify the terraform.tf var, make sure that the config file profile of OCI is default, which I have already configured this profile in .oci config. I have to specify the tenancy name. I have to specify the compartment ID to point to the demo OKE compartment. I have to specify the VCN name, OKE Demo, and this VCN name will be used for the DNS label for the VCN also. And that's all I changed in this TF var file. Before you can run Terraform script, you need to set one environment variable called custom search location, which will point to the PCA chn bundle file. This is important, otherwise you cannot run Terraform to connect to PCA. Okay, to use Terraform, first time you need to run Terraform init. So Terraform will check all the provider that it needs, and in this case they need OCI provider, so they just download from the net and install into this folder. After that, you can run Terraform plan to see what they're gonna do after you run Terraform apply. And you can see that there's a number of objects that they have to create it, like subnet, like another subnet with a number of subnet gonna be created, and the VCN have to be created and other stuff. Let's apply using Terraform apply command. When I key yes to confirm and apply, what Terraform will do is it will talk to PCA API and provision all the necessary resources that been specified in the Terraform script. Let's speed up this. All the resources has been finished provisioning. From the quick action dashboard in the Compute Enclave UI, when we select VCN, you can see that there's a VCN called Demo OKE provision in OKE Demo compartment. Now our virtual cloud network resources are ready. Next step is provisioning OKE cluster. So from the Compute Enclave dashboard, you can see there's a menu under section containers. Click into Kubernetes cluster, in parentheses OKE. At the top, you have to select the correct compartment, and now we have already provisioned VCN in compartment OKE Demo. So if we select this compartment, you can see that there's no cluster right now. The first step is create the cluster. What you have to do is click Create Cluster button. Create Cluster dialog will open. You specify the cluster name. Let me name it Cluster 1. Which compartment you would like to create that cluster in? Let's say OKE Demo. Kubernetes version. There are multiple versions of Kubernetes that you can choose. And the recent version as of the day I record the video is 1.28.3. So we select the recent one, and then you click the next button. The network type, right now we support only Flannel overlay. You have to select the VCN. The VCN is OKE Demo VCN that we have provisioned. And you have to specify which subnet you would like to put the service load balancer in. And we have a subnet called service LB for that. And then you have to specify which subnet you would like to provision the Kubernetes API endpoint in. And we have a subnet called control plane endpoint for that. And then you click next button. Now they just tell us that this step is creating the cluster. And after this, you have to create the node pool, which will automatically provision the worker nodes in the cluster. Click next. Okay, there's just some warning there. We can just skip it and then we just select submit. And now Kubernetes cluster will be provisioning. We have to wait until the cluster is provisioned. While the Kubernetes cluster is creating, you can see the progress of it. For example, you can go back to the quick action dashboard and take a look at the instance. And you can see now that in the same compartment, there's some compute instance automatically provisioned. And this is the control plane node. And if you click into that, for example, if I click into this node and take a look at the networking, you can see that this compute instance are provisioned and connect to the subnet called control plane. And that confirms that is a control plane node. Let's go back to the instance. Now all control plane nodes are provisioned. Let's get back to the OKE to see the status of the cluster. Now the cluster is active. Next step is creating the node pool for this Kubernetes cluster. From this screen to scroll down, you can see that there's a node pool resources. What you have to do is you click add node pool button. Name the node pool. Yes, I name it pool 1. Where you should create it, you specify the number of nodes that you want in the cluster. Normally you can specify 1 or 2 or 3. You can see that it can create up to 128 nodes in a single cluster. Scroll down, you can enable security group. I just leave it as default. And then you have to specify where is the subnet of the worker node, and it should be on subnet called worker. And where is the fault domain? I just let PCA to choose the fault domain automatically for us. And then you have to choose, I just leave it like platform image, and this is automatically select for us. It's Oracle Linux version 8 and Kubernetes version. The control plane has already been provisioned with 3 control plane node, and version is 1.28.3. This is the node pool. You still have choice. You can specify other versions of Kubernetes if you want to, but in this case, I would like to specify the same version for Kubernetes node. And then there's a dialog box for you to specify the shape of it. And we can vary. For example, each node I would like it to be maybe 8 OCPU and maybe 80 gig. I think it may be too big. Let's make it like 64 gig memory. And then you can specify something like boot volume. Okay, and then the other thing is the default, and you have a choice. You can specify the SSS key just in case that you would like to SSS into the worker node. I just upload one key as is. Okay, and then you can just click add node pool button. and then the pool is provisioning. If we go back to the quick action dashboard and take a look at the instances that has been provisioned in OKE Demo compartment, you can see that right now we have 3 control plane nodes. You can know that from the name that is a control plane, because in the instance name you can see the name like control plane there. This 3 node is a control plane node. And now there are 3 more nodes which are the word control plane. So it's definitely worker nodes, and it's provisioning 3 worker nodes for us. As we specify 3 worker nodes, each one of them have got 8 OCPU and 64 gig memory. We can click to check. This is one of the worker node. If you look at the configuration, it's 8 CPU and 64 gig memory. And if you look at the network, you can see that it sits in the worker subnet. I think all the worker nodes are now provisioned. We can go back to the OKE list. If we click cluster 1, you can see that the pool is still under provisioning. Now all the 3 worker nodes are fully provisioned and add to the node pool, and now the node pool is active. To access to Kubernetes cluster, the first step that you have to do is you have to get kube config file. And to do that, what you need to do is you have to copy the OSID ID of this OKE cluster. And then you go to the best and host that have OCI CRI command set up. And what you have to do is you have to run the OCI command. To get the kube config file for you for further use, what you have to do is you have to run the command. And the command is OCI CE cluster create kube config. And then you have to specify the cluster ID, which is the OSID ID of that Kubernetes OKE cluster. And then you have to tell them where you have to keep this file, and tell them that this is what we got. We want kube config endpoint. Now we got a file here. We have to export kube config equal this file. And then you can run kubectl command to check. Okay, now our OKE cluster is up and running.